we are going to look at the periodic table. The periodic table. So the periodic table contains 8 groups. It contains 8 groups, group 1 and group 0. Okay. Now, group 1 elements, actually, when we talk of a periodic table is the list of metals arranged according to the order of atomic numbers. It is a list of metals according to their atomic numbers. So the periodic table is divided into groups and periods. Okay, now groups, these are vertical arrangement of elements. Periods are horizontal arrangement of elements. So now, let's try to look at group 1 elements. Group 1 elements are also known as the alkaline metals. That's the other name for group 1 elements. Alkaline metals. Examples of group 1 elements are sodium, potassium, lithium, francium, etc. So these are group 1 elements. Now, in group 1 elements, the reactivity of group 1 elements, the reactivity of group 1 elements increases as you go down the group. As you go down the group. Meaning, the metal at the bottom of group 1 element is considered to be the most reactive element. And if you try to check the periodic table, you are going to discover that francium is at the bottom under group 1. So francium is the most reactive metal, or is the most reactive element in group 1. So francium is the most reactive element. Is the most reactive element in group 1 of the periodic table. Apart from that, group 1 elements actually they are all metals. They are all metals. Apart from that, group 1 elements can also combine with group 7 elements to form ionic compounds. For example, sodium can combine with an element from group 7 like chlorine to form sodium chloride. Sodium chloride actually is a salt. At the same time, it is an ionic compound. An ionic compound is a compound made up of a metal and a non-metal. So, considering sodium chloride, we are going to discover that sodium chloride is made up of a metal, which is sodium, and a non-metal, which is chlorine. So, it is considered to be an ionic compound. Apart from that, they have a valence of 1 electron. Okay, in their outermost shell. They have a valence of 1 electron in their outermost shell. So group 1 elements, the number of electrons in the outermost shell of group 1 elements is 1. Outermost shell is 1. Okay. So considering I'll give an example of sodium. Sodium has an atomic number of 11, then the mass number is 23. So now, let's try to pick the atomic number. So if we do the electron arrangement, we are going to discover that in the first shell, sodium must accommodate 2 electrons. In the second shell, it must accommodate 8 electrons. Then, how many electrons are remaining to get 11? Remember, atomic number is equal to the number of electrons an atom can contain. So meaning here we have 2 plus 8 is 10. So we are remaining with 1 electron. So what I was saying is that elements in group 1, they have 1 electron in their outermost shell. So if you came across this diagram, then you are going to say, what group does this element belong to? You simply have to look for the number of electrons in their outermost shell. Since it has 1 electron in its outermost shell, meaning it is likely to belong to group 1 of the periodic table. But if you are told, mention the period to which this element belongs, you have to count the number of shells. How many are there? We have 1, 2, 3. Meaning sodium lies in period 3, but group 1. Because why is it that it belongs to group 1? It has 1 electron in the outermost shell. Why is it that it lies in period 3? Because it has 3 shells. 1, 2, 3. So hence the number of shells determine the period, but the number of electrons in the outermost shell determines the group to which that element belongs. Now, let's quickly try to talk about group 7 elements. Group 7 elements. Group 7 elements are also known as halogens. This is the other name for group 7 elements. They are called halogens. Okay, so examples of halogens or group 7 elements include chlorine. So chlorine is an halogen because it is found in group 7. Then another one is bromine, iodine, fluorine, astatine. All these are what? Group 7 elements. Okay. Now in group 7 elements, the reactivity increases as you go up the group. So meaning the most reactive halogen in group 7 is fluorine. So fluorine is the most reactive halogen. It's the most reactive halogen. It's the most reactive halogen in group 7. All elements in group 7 are non-metals, but they have different physical states. For example, chlorine is a gas at ordinary temperature. Bromine is a liquid. At the same time, it can exist as a vapor at room temperature and pressure. Iodine is a solid. Fluorine is a gas, and astatine is a vapor or a solid at room temperature and what? Pressure. So many elements in group 7 or halogens, they exhibit different physical states at room temperature and pressure. So the family of elements belonging to group 7 are called halogens. So now halogens means what? The word halogen means salt formers. The reason as why group 7 elements are referred to as halogens or they are referred to as halogens, this is because they form salts. When they combine with the elements from group 1, they produce salt. Hence the word halogen means salt formers. Examples of halogens are chlorine, bromine, iodine, fluorine, and astatine. All these elements, they belong to group 7 of the periodic table. Then elements in group 7, they have 7 valence electrons in their outermost shell. Elements from group 7 have 7 valence electrons in their outermost shell. They have 7 valence electrons in their outermost shell. They have 7 valence electrons in their outermost shell. For example, chlorine, we are talking about 17, then the mass number is 35.5. So if I draw the electronic structure for chlorine, you are going to discover that it accommodates 2 electrons in the first shell. In the second shell, it has to accommodate 8 electrons, making a total of 10, plus the remaining 7 in the outermost shell. So meaning chlorine has 7 valence electrons in the outermost shell. 1, 2, 3, 4, 5, 6, 7. So since it has 7 valence electrons, 1, 2, 3, 4, 5, 6, 7 in the outermost shell, therefore chlorine belongs to group 7. Now, in what period does it belong? So you simply count the number of shells. How many are there? 1, 2, 3. So meaning chlorine is found in period 3 because it has 3 shells, but it's found in group 7 because it has 7 electrons in the outermost shell. 1, 2, 3, 4, 5, 6, 7. Thank you very much.